Okay, so this chapter is related to electromagnetic spectrum. Okay, so in this chapter, we need to discuss about those waves which are electromagnetic in nature. Electromagnetic means there is a property of electricity. It means in this type of waves, we are having a signal plus magnetic signal, right? So both type of categories or both type of properties, electrical and magnetical, are going to be involved in the waves, right? Actually, we are going to talk about those waves that we used in our daily life, like radio waves and electromagnetic waves like gamma rays, infrared rays, X-rays. All these types of waves are the example of electromagnetic, right? And first of all,
Right.
we generally discuss about the categories of wave. There are two categories, longitudinal and transverse. So first of all, if we want to write about the nature of electromagnetic waves, so what is the nature of electromagnetic waves or electromagnetic spectrum? Is it longitudinal or transverse? Because previously we talk about sound waves, and sound waves are longitudinal in nature because sound will always travel in a straight line and energy will also travel in a straight line. So sound wave is longitudinal in nature. And let's suppose if we talk about electromagnetic waves and electromagnetic spectrum waves, so all waves are known as transverse wave, right?
Mhm. Yeah.
So the nature of the electromagnetic waves are transverse. And why they are transverse? Because there are two type of waves include in a single, that is electrical and magnetic. It means that both electrical waves and magnetic waves travel perpendicular to each other, right? So that's why they
Right.
are transverse in nature. There are different types of waves that we are going to discuss in electromagnetic. So first of all, we talk about the properties. If they ask you about the properties of electromagnetic waves, so it is transverse in nature. Second one is, previously if we talk about uh, the sound waves, so sound requires some medium to travel, right? So it means that if we talk about electromagnetic wave, so they can easily travel through a vacuum, right? So they can travel through a vacuum. They can travel through vacuum. Just like we consider the example of the satellite and our mobile phone and internet connection. So they are working without medium, right? Because we can easily communicate through satellites, and we can easily communicate from one country to another one, and we can communicate worldwide. So there is no such specific medium required because these are electromagnetic generated waves. So it means that we don't require any specific or direct medium for that, right? So they can easily travel through a vacuum. It means that if we want to communicate in space also, so we can easily communicate with the help of electromagnetic waves, right? And one more important thing, that all type of electromagnetic waves travel with same speed, that is speed of light, right? They all travel with the same speed, and that speed is equals to speed of. And if we want to write the value for electromagnetic waves, so the speed for magnetic wave or the speed of light is equals to 3 into the power 8 second. This is speed for speed of light. Okay. And in this specific chapter, we are going to talk about 7 different waves or 7 different electromagnetic waves. And if we want to write the name of those electromagnetic waves, so those are the radio waves, microwave, infrared waves, and then visible. Visible light means all that 7 color, that is the white range of the light, because white light consists of 7 different colors, right? White light composed from 7 different colors. So
That
that is,
controls.
yes. So that rainbow color, same goes for the visible light. And then we have ultraviolet. After ultraviolet, we are having X-rays, and the final one, gamma rays. There are 7 rays or 7 types of electromagnetic waves. Those we need to discuss in our chapter. First of all, the most important thing is we need to draw a sequence for these type of waves, right? Sequence means we need to know that which wave has the highest frequency, which wave has the longest wavelength or the shortest wavelength. So that is the most important part of this chapter, because uh, half, or we can say that 50% of this chapter is actually depend upon the sequence of the wave, because most of the questions are related to the same concept, that you need to know which wave has the greatest frequency as compared to the other, or which wave has the greatest wavelength, like this. So we need to compare their wavelength, we need to compare their frequency. So that is the most important part of this chapter. So first of all, we need to draw the sequence of these type of waves. So first of all, let's start from the central part. So in the central part, let's suppose if we consider the visible light. So the central part is made up of the visible light. Okay. So in central, we are having a visible light. And let's suppose if we start moving towards right hand side. So on right hand side, we are having ultraviolet waves. In short, UV waves, right? And if we further move towards right hand side, we are having X-rays and gamma rays. So let's write it in the center. This is our central part, visible light. Then on right hand side, we are having UV rays. And again, on right hand side, we are having X-rays. And final one on right hand side, gamma rays, right? And let's suppose if we start moving towards the left hand side. So on the left hand side of the light, we are having infrared. Infrared rays. And on left hand side, next one is microwaves. And the last, radio waves, right? So this is the pattern, or this is the sequence of all 7 type of EM waves or electromagnetic waves. You need to memorize this whole chart or the sequence of the waves, and how it helps you to memorize the sequence of these seven different electromagnetic waves. You need to learn with the reference of their frequency or the wavelength, right? Let's suppose if we consider gamma rays, right, or x-rays, because x-rays, we use this term uh, commonly in our daily life. We use this type of application in the hospitals or in different medical field. So we know that x-rays are like a dangerous waves, right? Because they can easily
Yeah.
penetrate through our body. They are not able to pass our bones, but they can easily pass through the tissues, cells, flesh, or all the other skin of the body. So x-rays are like a dangerous type of waves that we are not able to uh, use in our daily life, just like a common use of normal light, right? So it means that if we compare, or if we just start moving from gamma rays to the radio waves, so if we compare them with the reference of frequency and with the reference of wavelength, so on right hand side, like from the gamma rays, we are having a highest frequency, right? Or we can say that the frequency will be greatest on right hand side. So if we talk about the frequency, so on right hand side, we are having a greatest value of frequency, that is the gamma rays has the highest frequency or the greatest frequency as compared to all other electromagnetic waves, right? And let's suppose now if we start moving towards left hand side, so X-rays has less frequency as compared to gamma, then UV waves have less frequency as compared to X-rays, and so on, right? So it means that gamma is greatest among all in the sense of frequency. And if we
And
talk
therefore
about,
the riskiest.
yes, and if we talk about their wavelength, so the wavelength for gamma rays is the shortest one, right? Because we know that frequency and wavelength both are inversely to each other. We already learned this concept in journal properties of wave, right? And let's suppose if we start moving towards left hand side, so on left hand side we are having the lowest frequency, and more thing, the largest wave, right? If you observe the FM radio, right? So FM radio is a type of radio wave, right? That's why we use a radio word for that device, because it actually works on radio signals, right? And you observe that the frequency was very much short. The channel that we tune on FM is known as like 99, 102, 105. So what is the meaning of that digit? That digit actually tells you about the frequency, right? So actually we are just trying to match our frequency with that specific channel, which is actually broadcasting over there, right? Let's suppose if we just try to tune 100 channel. So 100 channel mean 100 hertz frequency, and the station, or that we can say that the radio station which is actually broadcasting any program or any podcast, so actually it tunes that podcast in the range of 100 frequency, that is 100 hertz frequency, right? So actually on radio device, on radio wave, we are actually trying to match the frequency with the radio station, right? And once we got the same frequency, so your podcast or your channel on the FM is start to tune, right? So that is the actual working of radio waves in our daily life. We are just actually combining or just trying to match the frequency with the source of the frequency, right? Any confusion?
No.
Okay. And one more thing, if you want to draw a wave, let's suppose if you want to draw a wave for this whole seven waves in a pattern, so we will move like this, that initially we are having a largest wavelength, so our waves will move like a greater distance. Then this distance is going to be shrink, because now we are moving with shorter wavelength. And finally we are just in the compressed form like this. Okay, so now you can see that if we compare the wavelength, this wavelength is the shortest one, and on right hand side, sorry, on left hand side we are having a this wavelength, right? So waves will generate like this, that the rarefaction part is on left hand side and the compression part is on right hand side. And one more thing that we want to write for these type of wave, on right hand side we are having a higher energy. So the energy of the waves on right side is greater. So high energy on right hand side and the lower energy on this side. Okay. So and one more thing, let's suppose if we want to memorize this whole table. So basically there are 7 colors in visible light. Okay. If we talk about the visible light specifically, so there are 7 colors in visible light. And if we want to write the sequence of the light, so what is the sequence of the rainbow? If you
Red, orange, yellow, green, blue, violet.
Yes, so that is the sequence for the rainbow color. So it means that ultraviolet means violet is a name of color, right? So ultraviolet means the frequency of that violet color is greater as compared to the range of visible light. So that's why we use the term ultraviolet. Okay. And infrared means infrared is actually taken from the red color. So So in the visible light, when we are talking about the left hand side, so on the left hand side, we are having extreme red color on extreme left. And if we talk about the right hand side, so on our extreme right, we are having a violet color. Okay. That's why you just need to memorize this concept that on right hand side, we are having violet color. So we just mark UV, X-ray and gamma on right hand side. And on the left hand side of the visible light, we are having a red color. So from left hand side, we are having infrared, micro, and radio waves, right?
So basically, all the visible lights have many waves, right?
Yes, because in visible light, we are having 7 colors. So 7 colors have different range, different frequency, different wavelength, right? So visible light has
Mm.
different waves. We are having a 7 colors. So 7 colors means we are having different wavelength and 7 different range of frequency. Is the concept of visible light and those 7 colors, because each color is actually divided after several interval. So each interval shows you that a specific value of wavelength and a specific value of frequency. Okay. And higher energy higher energy means that we are having a higher value of frequency. So when the value of frequency is greater, so your energy will be higher. And lower energy means that your frequency is low. So when your
Frequency
frequency
is
is low,
low.
yes, so you have a lower energy. So this is the basic pattern, and this pattern is very much important because most of the questions and most of the concept are related to the sequence of the waves, right? Any confusion?
No, sir.
Okay. Okay. Starting from all these 7 ways, because in this chapter we need to talk about their application, their properties, their uses in our daily life. So that is our main concern in this chapter. And we can say that the 60% or 50% of this chapter is actually based on this sequence. Because when you try to solve your past papers questions, so you will find that most of the questions are related to the sequence only. So this table or this timeline is very much important for your questions in your past papers. So let's suppose if we first generally talk about these type of waves. So let's suppose we are having these 7 waves starting from the radio one. So the first one is the radio wave. So actually, in short, if we talk about their working or what are their actually use in our daily life. So first of all, if we talk about radio waves and microwaves, because both waves are like close range with each other. So starting from the radio waves. So first of all, if we talk about radio waves, so in radio waves, we can say that, as we already discussed, that in our radio tape or in our FM radio, we observe the same frequency. So actually, they are used to travel a long distance or a long range communication, right? So we use radio waves for long range communication. So the purpose of radio wave is to use for long range communications, long range communications is the main purpose. Radio, we use this type of wave in our FM signals. And what is the reason behind this long range communication? The reason is that reflect from the Earth's atmosphere, right? If you remember the concept of diffraction, so in the concept of diffraction, we studied that deflection or reflection through the edges, right? So that's why we use radio waves, because what is the main purpose of the radio wave? Radio wave actually have the longest wavelength, right? The longest wavelength. So longest wavelength mean it can easily travel through long distance, because on the left hand side of our timeline we are having a radio wave. It means that the largest long or the longest wavelength, so they can easily travel through long distance and they can easily reflect through the earth atmosphere or the object, just like any reflecting surface, the mountains, cliffs, hills, buildings. So that's why we use radio waves for communication and for transmission, right? Okay, any confusion?
No, sir.
And a more common example in our daily life that is related to radio wave, which is actually is your main daily life application, that is Wi-Fi. So actually Wi-Fi also works on the radio signals or the radio waves. Next, the radar system in airplane or the ships actually uses the same frequency. Phones and radio tape is also the application of radio waves, right? So this is the
Right.
main purpose of radio waves in our daily life. And second one is microwave, and microwave is very much closer to the radio wave. So it means that the purpose of microwave is almost like the same. We also use microwave for the transmission process. And what is the difference between radio wave and the microwave? Because both are close to each other. And let's suppose if we are going to use them for the same purpose of the transmission, but still there is a difference. And what is the difference? Let's suppose if we talk about the micro. Okay, one more important thing. Whenever you try to dial someone number to call him or her, so whenever we are trying to dial the number, so actually that specific number is set on a specific frequency, right? Because whenever you try to dial a specific number, so your phone number is actually connected with that specific number, right? There are million of numbers around you, but still your number is only connected with that specific number, right? So actually, what is the science behind this connectivity? So the science behind this connectivity is that they have their specific frequency, right? So they actually match your frequency to the frequency of that specific number, right? So they are still working on the frequency, but for our daily life use, they just use a number or digits to simplify our daily life. Otherwise, we need to just tune the frequency just like the old walkie-talkies and the radio signal. So that's why they all work on the concept of frequency and the wavelength. But for simplicity, we use those SIM numbers to just dial or to communicate through worldwide. Okay. And now, if we talk about the microwaves, so there are a million and billions of waves around us, right? Because in our daily life, we are having many millions of electromagnetic devices in our atmosphere, and those waves are actually moving in our atmosphere. So there may be intersection between those waves, so there may be some distortion. So how we can just separate these radio waves with microwaves? Because let's suppose if someone is trying to communicate with the satellite, okay, so those waves are actually again moving from our same atmosphere, but we will never we can say that intersect those waves, or there will be no intersection between those waves. So how we can separate? We can just select a specific range for the radio waves, and then we select some specific range for the microwaves. So microwaves are actually used to communicate with the satellites, right? So if we talk about the microwaves, so microwaves are especially used to communicate for with the satellite. Okay. So for satellite communication, we only use microwaves, because if we use the radio waves, so both waves will intersect each other and there will be a distortion between microwaves and radio wave. So that's why we need to keep the change, and we need to keep a different range of microwaves and radio waves, right?
Yes.
And one more thing, what is the reason that we are using the microwaves? So in radio waves, we write that they can reflect from the Earth atmosphere. And for microwaves, we can say that they can penetrate through, they can penetrate through atmosphere, right? Because we know, as we are trying to move towards right hand side, so we are getting a higher frequency as compared to the previous one. So that's why microwaves can easily penetrate through the atmosphere of the Earth's surface, right? So that's why it is easy to communicate with the satellite with the help of microwaves, right? And if we talk about the wavelength and frequency, so we can say that microwave greater frequency than the radio waves, right? And for the application, we already said that we use in the satellite communication, or we can use it for the communication with and all other things, right? That away from surface, right? And if we talk about the third type of wave, which is known as infrared waves or infrared rays, term is because ray is a type of a source of light, we can say that, or source of electromagnetic light that always travel in a straight line, because light always travels in a straight line. So these all types of waves are moving in a straight line. So that's why we are sometimes use the word rays over there, because rays actually moves in a straight line. We also discussed this concept in the chapter of light. And if we talk about infrared rays, now we are having a greater frequency as compared to the microwave. And what are the actual use of infrared in our daily life? These infrared rays are used for optical communication, right? Optical communication means, let's suppose if we use any remote control car or remote control of a TV or remote control of any device. So if you observe that when you press the button of that remote, so actually there is a blue light or a red light on that device, right? So when you press the button, so that red or blue light blinks, right? And when we try to observe that light from our normal eye, so we are not able to observe that light from our normal eye. And but let's suppose if you place a camera, mobile camera in front of that remote, and when you try to press the button of that remote, so you will observe that light with the help of that mobile camera. So mobile camera actually captures that source of light, which is infrared. We are not able to observe that light because we are only able to observe that visible light range, 7 colors, right? But cameras are able to observe that light. You also observe that red light in CCTV camera in night time or in night vision, because in daytime there is no light on CCTV camera, but in night time, let's suppose if there is a complete dark region, so you observe the CCTV camera that there are red LEDs are connected in that CCTV camera, right? So those are infrared rays. So the main purpose of using the infrared rays in our daily life is for optical communication, right? Or we can say that optical fiber communication. So this is the main purpose of the using infrared rays in our daily life, that we use in optical fiber communication. And what is the reason behind it? So the reason behind it using infrared ray is they undergo total internal reflection. Total internal reflection concept related to the discuss this also. But in simple, we can say that when light enters from one medium to another, let's suppose when light travels from the remote control to the TV or any device, so it can easily reflect inside that medium, right? Not outside from that medium. Okay. And one more thing we can say that for the infrared rays, that these type of wave can also be emit. These waves or be emit to warm bodies, warm object. Let's suppose if we consider any hot metal or any warm temperature body, so that body will also emit infrared rays, right? And you also observe this application in many movies or in movie clips, that we use laser light for this purpose. And those laser light also works on the same principle, right? Because they are also moving in a straight line, and we use infrared technology in making security system or in security alarms, right? And if we talk about the applications, so for application, we already discussed that remote controls, CCTV cameras, or security camera, we can say that, because they are able to see in the night vision because of that infrared part. Okay.
All right.
So these are the applications and these are the properties of radio waves, microwaves, infrared waves. And this is the timeline for your light wave and your light pattern. So this is the initial part of this chapter, right? Then next we have visible ultraviolet X-rays and gamma rays. And after that, we only need to talk about their dangers, that which light is danger or which one is safe to use in our daily life, right? And that will be the end of our chapter. Then we have only left out with one chapter, that is of light. And after that, we done with this section of whole section of waves, right? Then we are only left out with the questions that we need to solve from topicals and from past papers. Okay.